Hey there, let's talk about the identity x plus a times x plus b. Before we dive in, let's recall the distributive property of multiplication. When you have a number and you're multiplying that by brackets, you know that the number will be multiplied by each of the numbers individually. So 5 times 7 plus 8 becomes 5 times 7 plus 5 times 8. This is known as the distributive property of multiplication. Similarly, instead of 5, you had 5 plus 6, which is actually 11, but you could write it as 5 plus 6, correct? So you would multiply the entire thing first with 7 and then with 8 individually and then add them up. So that would give you 5 plus 6 times 7 plus 5 plus 6 times 8. Now let's try and expand the identity. X plus a times x plus b. So we first multiply x with x plus b and then multiply a with x plus b. So this becomes x times x plus b plus a times x plus b. So we are distributing this expression with this expression. So x times x plus b plus a times x plus b. And then we distribute this further, x times x plus x times b. And then a times x plus a times b. So that would give you x squared, x into x is x squared, x into b is xb, plus a into x is ax, and a into b is ab. So x into x becomes x squared, x into b becomes xb, a into x becomes ax, and a into b becomes ab. Now further we can make this into a singular term because if you take x common, so you have xb plus ax, which is actually xb or xa or bx plus ax. It's the same thing, correct? So if you take x as the common factor, you get x times b plus x times a, which is x times b plus a plus ab. So finally you end up with x squared plus x times b plus a plus ab, or it could also be x squared plus a plus b into x plus ab. This term can be written in multiple ways. It'll all be the same thing. So as we saw, x plus a times x plus b, the identity is x squared plus a plus b into x plus ab. In this, x squared is the square of the common term. The common term is x. This is the common term, correct? X plus a times x plus b. So x is the common term. And this is the square of the common term. It is x squared plus sum of the constant terms multiplied by the common variable. So whatever the constant terms you have a, one constant is a and one constant is b. So you add them up and multiply it by the common variable. So x squared plus a plus b into x plus product of the constants. That is what the identity gives you. You might be better off by remembering it and not always trying to solve it multiple times. So x plus a times x plus b gives you x squared plus a plus b into x plus ab. Let's try and tackle some questions. Example 1. X plus a times x plus 4. Our expression is x plus a times x plus b. So what is x? X is the same as x here. Now a is 3 and b is 4. So let's color them. So a is 3 and b is 4. So what do we have from this? X squared plus a plus b into x plus ab. Let's apply that. So we get x squared plus 3 plus 4 times x. A is 3, b is 4. A is 3, b is 4. So 3 plus 4 times x plus a into b, which is 3 into 4. What is 3 plus 4? 3 plus 4 is 7. 3 into 4 is 12. So we have x squared plus 7x plus 12. So overall you get x plus 3 into x plus 4 gives you x squared plus 7x plus 12. That's how you solve questions, and that's where our identity becomes really useful. Let's try a different kind of question. 105 times 107. And our expression is x plus a times x plus b, which is our identity. But how is this related to this? Here is how. If we write 105 as 100 plus 5 and we write 107 as 100 plus 7, then we get the same kind of expression. So 100 is our x here, a is 5 and b is 7. So our expression is x squared plus a plus b into x plus ab. So 100 square plus 5 plus 7 times 100 plus 5 times 7. X square is 100 square, a plus b is 5 plus 7, x is 100, ab is 5 into 7. So now we can simplify this further. So 100 square plus 5 plus 7 times 100 plus 5 times 7, which is 10,000 plus 5 into 7 is 5 plus 7 is 12 into 100 plus 5 times 7 is 35. So 10,000 plus 1200 plus 35, which is 11,235. That's also one way which you can multiply complicated terms without having to go through multiplication. That's a very useful application of this identity. Now let's see some variations of the identity. X plus A times X minus B. So instead of a plus, we have a minus. So how does that change the expression? We get X squared plus A minus B times X minus AB. Everything remains the same. Instead of A plus B into X, you get A minus B into X. If the minus is here, X minus A into X minus B, then what happens? Then we get B minus A. You get X squared plus B minus A into X minus AB. Instead of A plus B into X, you get B minus A into X. Now one last variation is X minus A times X minus B. That gives you X squared minus A plus B into X plus AB. So we have, instead of plus, you have minus X minus A into X minus B. So you get a minus here instead of a plus. So X squared minus A plus B into X plus AB. These would also be pretty handy when you're solving some questions. And here's a bonus question. Can you do the reverse? If X plus A into X plus B is X squared plus 12X plus 35, can you find the values of A and B? Give it a shot. I'll see you next time.